Thank you for coming. My name is Edward Holden. I'm with HPE. I manage the business development and strategy pertaining to the Cloudline division within HPE. We're going to talk about an autonomous driving kind of point of view and proof of concept solutions that we've been working on at HPE using Cloudline systems and open standards, commodity hardware, and open source software. Before we go, I want to level set a little bit, a couple of things just to make sure everyone is familiar with Cloudline. Those of you that aren't, we are a group within HPE focused on selling to service providers and the larger volume customers all over the world. We are focused on open standards hardware. So when you hear Cloudline, you wonder maybe what's different between that and ProLiant. The big difference is we build open standards-based hardware. So we don't use ILO, we don't use proprietary BIOS and firmware, we use regular off-the-shelf commodity hardware to get a more open standards-based system to our customers that are looking for scale and have resources and are familiar with open source tools and have the capabilities to do that with themselves, and maybe they don't value some of the extra things that would come with a ProLiant. So that's what Cloudline is focused on. So when we're talking about autonomous driving, a lot of this is going to be pertaining to the edge and analytics at the edge. So we're really focused on the edge and where that's going when we hit 5G and moving forward in the future, and how that relates to autonomous driving. So right now, it's kind of the Wild West out there with autonomous driving. We have most of the major manufacturers already deep into proof of concepts, testing, different ways of putting together their autonomous driving solutions, figuring out best ways to do that, what open source packages to use, what hardware to use, how much they're going to need. A lot of data is required in this. They're estimating currently that an autonomous vehicle will generate about 4 terabytes of data per car per day. So we have large amounts of data that needs to be stored, and also a lot of analytics that needs to happen real time in order to get the information from the cars to the data center and back to the cars to be viable. So right now, if we were to look at how this is done today, obviously there's not a lot of autonomous vehicles around today, and that's for a few reasons. A, we have a limit to the latency and the bandwidth that's available at the current 4G cellular architecture that's available. And right now, we have cloud data centers, different regions that have either Amazon or Microsoft or other large cloud data centers where the data has to go back and forth and is stored. So right now, just to give you an example, 4G network going to a cloud data center from an autonomous vehicle, you figure you're about 500 miles away round trip for the data to go from the car to the cell tower to the data center and then back. That's going to be about an 80 millisecond latency. And just to give you an idea of what that means is a car can travel probably about 4 feet in the amount of time it takes the data to go from the car to the cell tower to the cloud data center and then back. And obviously, when you're doing real-time analytics in a car that's going 70 miles an hour, that makes a big difference, the latency and the time it takes to go round trip for this data in order to control these vehicles. So with the advent of 5G coming up, this is going to get a lot better. We have the latency is going to go from 50 to 80 milliseconds down to 5 milliseconds. We're looking at doing micro data centers near cell towers. One of the big advantages of 5G is it's really made to work in like a mesh network. So you're going to have distributed data centers across the countries in order to get the latency down. So you're going to have the speed of 5G. You're going to have micro data centers near cell towers or smart cities, however they're going to implement it. And that'll get your latency down to about 5 milliseconds. So we go from car being able to travel 4 feet to traveling 4 inches in the amount it takes the data to go round trip from the vehicle to the cell tower to a micro data center located near the cell tower and then back. Now, there are different companies focusing on micro data centers. HPE obviously has our modular data centers. We saw presentations today. Other companies having micro data centers. Companies like Vapor.io with their vapor chamber looking to put micro data centers under cell towers. So you're going to have these cell towers pop up, sorry, these micro data centers pop up near cell towers in order to give you the distributed data centers across the geography, which is going to give you the increased latency that drones and autonomous vehicles, any kind of autonomous vehicle is going to need in order to make these real-time analytics happen. So we've been working on some proof of concepts with customers. I want to give you a little example of what this looks like for a typical autonomous driving configuration. So you're going to have your IoT event producers. In this case, that's going to be the vehicle. So the vehicle is going to have sensors, radar, LiDAR, video. All that data moves from the car, uploads through the cellular network to the micro data center or the cloud data center, depending on how it's being implemented. And you're going to have kind of different tiers of where this real-time analytics happen at the edge. So your edge analytics are going to be, you're going to have your fast data. So you need to have, like NVMe drives preferably to handle the fast data. Then it goes to another server for big data. You're going to have, obviously, this is more your Hadoop, Cassandra type workloads. And then after that, you're going to have a data lake. So this is your object storage. So, again, as I said, we're looking at about 4 terabytes per car per day of data being generated from autonomous vehicles. So this data will need to be, stored after the real-time analytics are done. They're going to be stored in a data lake where additional analytics will be done at a later date. That's where the vehicle manufacturers and whoever's running this will get additional information out of that they mine. So what does this look like when we talk about a Cloudline solution? So again, we can do this with multiple systems, but in a Cloudline configuration, we're talking about using Open Compute inspired products to build this POC. So we have a couple available for the IoT aggregator. So again, the events come in and the data is ingested. Primarily, we'll use a Cloudline 2200 or 2800 server. 2800 is soon to be released, but we have one on the floor if you want to take a look at it. It's your basic 2U with 12 large form factor or 24 small form factor SSDs. That data then goes to the fast analytics Kafka cluster. Now I'll talk a little bit about the different open source packages that we're using for the data mining and analytics here shortly. But the Kafka cluster is basically a messaging system for the real-time analytics and streaming data. We have Zookeeper on top of that to basically manages all the configurations and synchronizes the service. Using our Cloudline 3100, this is a 1U with 20 NVMe drives. We are processing 1.3 million messages a second coming in from the IoT feeds. That then moves to our big data connector, again running Kafka. We are now serializing this and converting it to S3 format data. We are doing that at about 128 messages kind of processed and serialized within 24 hours. So again, the first one is your real-time data, and then the second one is now taking that data and formatting it into a S3 style. And then it goes to your data lake or your object storage. We have a couple different servers we can use for that. In this one, the proof of concept was the Cloudline CL 5200. That is a 4U chassis with up to 80 large form factor hard drives. We have a new version called the 5800, which is actually 100 large form factor hard drives in a 4U chassis. So again, this is going to be all your object storage is going to be in there. And then you can use that at a later date to all the data mining that happens after the real-time analytics. So as you can see, you go ingest, you got your analytics happening in the middle, and then you have your offloading to object storage. So all this is happening edge to cloud. We start the real-time analytics close to the source in a micro data center near the cell tower, and then the object storage you can be done either locally, again, in your micro data center, or offload that to Amazon Cloud or Microsoft Azure storage cluster as well. The software that we are running on that is based primarily off what's called the SMAC stack. So again, that's going to be your Apache Spark, your Mesos, your Akka, your Cassandra, your Kafka, and then we've added Flink on here too. So there's different ways to do this. Again, multiple vendors are running proof of concepts, trying to figure out what's the best way for them and their topology. So we are working with customers, building proof of concepts, getting them to run their code on it. I think there's going to be no right way to do this, but we want to keep all options open. On top of that, again, we have Apache Zookeeper to manage the configurations. Kind of an example of what this would look like in the actual proof of concept that we did. Again, you have your event pipeline, so your data coming in from your IoT, the cars. That's going to go to your fronting Kafka cluster for your data serialization. And then it uses Apache Flink, and then to the object storage on the CO5200s running Scality Ring. So again, you can have your object storage formatted into S3 format, stored internally in your own Scality Ring cluster, or then exported into Azure or Amazon S3. So again, this allows you to have multiple copies in different locations. Again, 5G is going to allow you to do mesh networking, so you don't need to rely on large cloud data centers to manage everything having the lower latency it takes to get farther away. You're going to have these in micro data centers located under the cellular towers. It's kind of how people are envisioning this so far. I think we are about at time. I know we're kind of going back to back here with presentations, so we might have a couple minutes for questions. Otherwise, I will be at the HPE booth the rest of the show if you have any questions on this. Again, I have all these Cloudline servers that we showed here are down at the booth if you want to take a look at HPE hardware based on open standards hardware. We can do a little show and tell there. I thank you all for your time. Have a good afternoon.